Hello guys, so I would like us to look at how to go about solving this. So you've been given u, which is ln x squared plus y squared raised to power half, and then you're being told to show that del 2u del x squared plus del 2u del y squared is equal to 0. Now, recall how to differentiate a logarithmic function. If you have a logarithmic function ln f of x, its derivative is given by, you write f of x in the denominator, and then on the numerator, you find the derivative of what you've written in the denominator. So in a similar manner, that's what we are going to do. We have ln x squared plus y squared raised to power half. Remember, this is partial derivative. This is our u. Now let's evaluate del u del x. Differentiating this function with respect to x. So we are first of all going to write the whole function on the denominator, x squared plus y squared raised to power a half. Then on the numerator, we're going to use chain rule to differentiate. Now using the shortcut chain rule, we will have a half into x squared plus y squared raised to power a half minus 1. Multiply this by derivative of what is inside, and what is inside is x squared plus y squared. If you differentiate this with respect to x, you get 2x, and this gives you 0. So that's what you get. So simplifying this, the 2 and the 2 will cancel. So you have x into x squared plus y squared raised to power minus a half over x squared plus y squared raised to power a half. So bring this down here, the power will become positive. So you will have x, this is raised to power half. If it comes down here, and this is also raised to power half, since they're the same, you add the powers, and we will have x squared plus y squared raised to power 1. Now we need to differentiate again this so that we get the second derivative. So we will use quotient rule. Let this be u, let this be v. So we are looking for u prime v minus v prime u, all this divided by v squared, which is del 2u del x squared. Now, what is our u prime with respect to x? If you differentiate x here, you get 1. What is our v? X squared plus y squared. Minus, what is our v prime? If we differentiate this with respect to x, this gives us 2x, this gives 0. So we have with respect to x, we have 2x there for our v prime. And then what is our u? Our u is x. All this divided by v squared, which is x squared plus y squared and squared. So this gives x squared plus y squared minus 2x squared. All this divided by x squared plus y squared squared. If you simplify the numerator, x squared minus 2x squared, so we have y squared minus x squared over x squared plus y squared squared. That is our del 2u del x squared. Now let's look for del u del y. Our u is ln x squared plus y squared raised to power a half. So what is our del u del y? Come and write the whole function here on the denominator, and then up find its derivative using the shortcut chain rule. So a half x squared plus y squared. Remember, we are differentiating with respect to y. So multiply by derivative of what is inside with respect to y. If you differentiate this with respect to y, you get 0. With respect to y, we get 2y. So simplify, we have y into x squared plus y squared raised to power minus a half over x squared plus y squared raised to power a half. Bring this down here, the powers will combine because they are the same. So we'll have y x squared plus y squared. We need to differentiate this again. So since it's a quotient, we use quotient rule. Let this be u, let this be v. So to get del 2u del y squared, we use u prime v minus v prime u. So u prime, if we differentiate y with respect to y, we get 1 multiplied by v minus v prime with respect to y, we will get 2y multiplied by u. All this divided by x squared plus y squared squared. So on top we have x squared we have y squared minus 2y squared if you open this up. So that will simply give us minus y squared. All this divided by x squared plus y squared squared. So this is our del 2u del y squared. Now let's look at our del u del y. So if we add them, what do we get? So our del 2u del x squared is y squared minus x squared. So this is x squared minus y squared over x squared plus y squared squared. Add 2y squared minus x squared over x squared plus y squared squared. The LCMs are the same, so we can just go ahead and add the new. The LCM will be x squared plus y squared squared. And then on top, we have x squared minus x squared will give 0. Minus y squared plus y squared will give 0. So this eventually just gives us 0, hence the proof.